Okay, looks like most people have managed to get in. I'm sure there'll be a few more that join us along the way. Yes, as I said, Simon Pearson, I lead the digital and data team within the Energy Systems Catapult. So the first thing I'd like to do is just say welcome to the event today. This is the second in a series of events we've got running this week. Each one is focused on the opportunities and challenges that digitalisation brings to the energy system and how critical it is in the transformation of our energy system to a low carbon solution to meet our 2050 net zero targets and obligations. Each day this week, we're going to be exploring a different aspect of digitalisation and the role that particular, not necessarily technology, but I guess discipline perhaps is a better word, might play in that transformation. And today's session's focused specifically around data science and AI, and how critical it already is and how increasingly critical it's going to become for that transformation as we go forwards. We know that the future energy system is going to be more complex, it's going to be more distributed, it's going to have increasingly intermittent and therefore unpredictable in some cases, or less predictable sources of energy. And it will need to be more integrated and interoperable. So all of those things give great opportunities, but they also create many headaches, which the team will talk about shortly. And there's another factor that comes in here, I think, that becomes increasingly important, which is around behavioural driven aspects. You know, the uptake of EVs or heat pumps and all those things are much more behaviour driven, and we need to understand what impacts they have on things going forward. And I think data science and AI and machine learning and all of the disciplines that underpin those are going to be critical to some of those things. My colleagues, Anthony Woolcock and Usman Farouk, are going to walk us through some high-level materials that we've got, and there will be a report, I think it's being published today, that has more detail around these. I'll hand over to those in just a minute, but hopefully you'll find the session today both informative and enjoyable, and that there will be some things posted in the chat to give you the opportunity to express your interest in further discussion beyond the session today. So thanks very much, and without further ado, I'll hand over to Anthony.
Thank you, Simon. Welcome everybody. I'm really excited about this afternoon, and hope you are too. Running order, essentially there's about 20 minutes of slides, so we're going to be going through some of the high-level ideas that we've been thinking about here at the Catapult in terms of the challenges and opportunities for AI and in the energy sector, and then we have our roundtable discussion with 3 distinguished guests, and again that will probably be about 20 minutes where we have an opportunity to hear from them what some of the challenges that they're facing and you know, the solutions that they're working on in their different domains. And then there might be a bit of time for questions at the end, and the way we'll manage questions from the whole group will be, if you can post them in the chat, we'll monitor those at the end, and if we have time we can raise some of those questions with the panelists. So essentially it goes slides, and then the roundtable discussion, and then questions at the end. But we won't be taking questions verbally, we'll just be doing them through the chat. So at any point you want to raise a question, by all means do add them to the chat as well. So the slides presentation is going to be from me. I'm Dr. Anthony Woolcock, lead data scientist here at the Energy Systems Catapult, and my colleague Usman Farouk, who's one of the data scientists here, and we're going to be running through those slides now. So AI in the energy sector. What kind of topics can we think about? What kind of themes can we think about? What kind of challenges can we consider? These are some of the questions that are going to be coming up in the roundtable discussion, and they're very broad, and we'll be hearing thoughts on those later on. But right now we're going to dive into some of the questions that we've been looking at. And these are specific challenges and specific opportunities within 4 different areas. So we've had to think about where energy is coming from and where it's going to. And in terms of thinking about where energy is coming from, that's to do with the networks and to do with markets. And then there's 2 potential end users, that's both transport and for the domestic setting. So that's behind the meter. Before we dive into that, I'm going to explain a little bit of our personal view of what AI is. And I suspect everyone has a slightly different view. Really, AI, artificial intelligence, and data science are themes, or you know, doing words or verbs. So typically AI is around enabling computers to think, and data science is around understanding data. So these are much more to do with topics or to do with departments. And actually the techniques used within both of these areas are machine learning techniques, statistical inference, and potentially sometimes specific AI techniques to do with deep learning. So the paper as a whole and the discussion is intended to cover all of these, but we've used AI as a theme word, as a topic word, to cover as much as possible. So clearly artificial intelligence in our context is primarily about control and automation. And data science covers a whole range of different techniques, specifically statistical inference and machine learning. And then within machine learning, you have many different algorithms which people have been working on. So if you're new to the area, hopefully that gives you a bit of a snapshot of what AI is in the context of some other words that you've heard as well. So right now we're going to dive into some of the areas that we've been looking at. And that's first of all, networks and markets. And I'm going to hand over to my colleague, Usman, who's going to take us through those.
Thanks, Anthony. Hi, everybody. We'll walk through the networks. When we think about networks, what we're really thinking about is the physical asset that really allows for energy that's created somewhere to be utilized somewhere else. What we've seen is a real shift from what that should look like. And we think about this at three levels: at the macro level, at the network, and at the household. So at the macro level, we're talking about aspects such as integrating wind and solar and other renewable energy sources, essentially looking at how, from a physical perspective, we can integrate sources which have variable supply, intermittent supply, what network upgrades do we need to do, where should they happen, etc. The network level, really what we're looking at is the network's going to change in terms of how it's used. So we'll have not only consumption, but we'll also have people and assets sending electricity back into the grid, so bidirectional. And we'll also have a lot more and a variety of assets which are used, which weren't previously used, which weren't previously utilized. And so making use of those assets, allowing for data to be shared, available to parties who need to use that data, whether it be grid or aggregators or other people who are involved in the network, to be able to make the decisions and allow for the grid to operate in the way as we know it does. And thirdly is the household level. So on an individual level, we're going to have an increase of monitoring, data provisioning of how the electricity consumption in that household is or what it is. But also that is really just going to reflect the demand and how it can be managed. And that is partly based on changing in behaviors, i.e., we've got EVs, we might have changes from gas to electricity in terms of heat, and also we might have storage devices. So this combination of behaviors and assets will essentially change the demand in a way that we don't really know, and how will that affect the grid? These three challenges we think AI can support in a number of ways. I think firstly, looking at the macro level, stability and ancillary services are so key to ensuring the grid operates in the way we're used to it operating. So no blackouts, trips, etc. And so really looking at how things are correlated and if there's causation and how we can understand that better using the data. I mean, there's a lot of aspects of stability from frequency and voltage, etc. But making use of all the data in a way, in a time frame that's required, is something that AI can really support. We also feel that given the complexity of the grid and how it's going to change, new performance metrics, which are time dependent and also location dependent, can be developed and utilized to monitor and assess the grid and how it's performing. This is going to be particularly of interest when we're looking at local energy systems and we're looking at grid stability in local areas versus the macro level. From an asset perspective, whether that be on the networks or whether that be at household community level, fault detection and condition monitoring will be key. Condition monitoring to make sure the assets are essentially performing in the way we'd like them to, in an economic way. And fault detection is even more key, as it ensures that, you know, even if we do have stability and ancillary services working as they should, if there's a problem in the system, it's detected, so not to cause, you know, cascading failures. And also, when thinking about AI in the use of design and test, there's still much in the space which needs to be designed. It's not something that's happened. We're still in the process of designing upgrades, designing particular systems. So ML, as an example, you know, calculating optimal power flow, can support, you know, fast iterative design, prototyping, and assessment of those designs to see, you know, what is the best solution or what is the combination of solutions which allows for the grid to work in the way that we expect it to. This leads us onto markets. So while the network is a physical asset that allows for electricity to move from where it's needed, the market is something bit of a more of an invisible mechanism, which is built upon that transmission system. And traditionally what we've seen is kind of static supply. We've got our power plants, and demand is what really needs to be forecasted. So, you know, bank holidays, seasonality, etc. And in order to match the demand with the supply, we've had, you know, ramping up generators to come online. Essentially, the ESO will dispatch to meet that demand at a particular time. We've got marginal pricing system, which allows for that decision to be made in an economic fashion. But really, the challenge is now that not only do we have to forecast demand, which is becoming increasingly variable and different with the use of different assets in the home, we've also got to forecast supply. Supply is intermittent, supply is uncertain from renewables. And then when it comes to dispatch, we've got assets on both sides of the grid. So we've got demand response at the kind of residential community level, where we've got aggregators as well, which have the capacity to move demand, you know, peak shaving, etc. But we've also got dispatch assets such as storage at a grid level, megawatt level, for maybe ancillary services, etc. And that is a much more complex system, and ensuring all those assets are commercially viable, done in a fashion which incentivize further investment into the grid, is quite complex and challenging. So we think that AI can participate in ensuring that the market becomes as quote unquote efficient as it possibly can. Firstly, by ensuring accurate forecasting. Short-term to medium-term, perhaps even long-term forecasting capability allows better decisions to be made. When it comes to dispatch, how can we optimally dispatch when, you know, across the levels, from residential aggregation at community level and at a network, to meet the demands, meet all the stability and ancillary requirements. And then price. Price is interesting because we're looking at a grid which is more time dependent and also location dependent. So does that mean that we start pricing, looking at geographical variables, looking at new flex markets, geographical variables like marginal pricing at locations, etc. Essentially, we can utilize the data that's available at a macro and a community level to price so that assets can get their return on investment, essentially, and continue to be incentivized to invest. Anthony, I'll pass it on to you.
Thank you. So we've heard a little bit about where energy is coming from, both in terms of the networks and in terms of the markets. And we also thought about where is energy being used now in terms of two of the key large uses of kind of high carbon energy at the moment in the UK is both transport and in terms of heating homes and energy use in homes. So in terms of transport, some of the key challenges are the fact that right now there's a large proportion of carbon emissions coming from the transport sector. Potentially, there's going to be an increase in energy with different energy uses from different vehicles in the future. And actually, we need to reduce that. So, number one, we need to reduce the energy that is being used by the transport sector. And secondly, we need to use it smarter. So this is both efficiency in terms of transport as a whole, multiple stage journeys, public transport, those kinds of things, but also efficiency in terms of vehicles themselves. And one of the key areas for that is charging. So, placement of chargers, where's most optimal for those, and then charging patterns as well in terms of fleet and those kinds of things as well. So this is a really large area that needs to be looked at in terms of what's going to happen, both in terms of energy reduction and in terms of improving efficiency. And there's two key themes there in terms of efficiency. There's both travel as a whole in terms of journeys and vehicles specifically as well. So this includes batteries, manufacturing of batteries, use of batteries, and the life cycle and those kinds of things as well. So these are two key areas that we see as need to be improved. And there are, progress being made, but there's still a long way to go in terms of progress there. The other big area is behind the meter. So this is the domestic setting, which is primarily heating, which needs to move from gas through to electricity in terms of being the primary supply of people's energy for heating, but also other energy uses in the home. And one of the key things is that devices are going to multiply in terms of what people are using. So there's big questions around interoperability, and then there's big questions around how those devices are controlled. So this comes back to AI and control and automation, and considering exactly what Simon said, which is people's preferences and individual preferences for how devices are being used. So within this context, clearly going from gas to electricity is one of the big drivers for why behind the meter is really important, but also the devices themselves. For example, electric vehicles coming online. So within homes, there's going to be more devices like electric vehicles, solar panels, these kinds of things, which is increasing the complexity, both for the end user and for the market context. Now, from the end user's point of view, they want to reduce that complexity and just, get what they want. They want to be able to have the heat when they need it and the electric vehicle charge when they need it. But if you've got, a plethora of devices, you need some assistance with this. And this is where AI can come in terms of scheduling and optimizing specific devices, but also by managing multiple devices and choosing what you do with those. So some of those solutions we can see through interoperability, some of those we can see through specific optimization, and some of those we can see through patterns learned from data, from AI. And the little diagram in the middle there is just like a nice cartoon snapshot of, potentially choices that you have to make if you have multiple devices. The first one, maybe you decide not to sell back to the grid, even though the cost of electricity means that you might, because it's actually sunny everywhere else and the cost has come back down again. So you use electricity. The middle one, potentially you have more expensive electricity that you can sell back to the grid. And the last one, potentially AI has learnt your preference in terms of your route planning and which days you use your electric vehicle. And then the decision is made to help you charge up your vehicle. So the story there is an increased number of devices and increased complexity. And AI is one of the solutions that can help reduce complexity for the end users. So before I move on to the roundtable discussion, I just want to kind of pull out some of the key themes that we've seen there and how the Catapult works with those. So we're looking at how AI and ML can be deployed in different contexts. And we're part of whole systems thinking in terms of considering multiple actors across multiple different domains. And actually the question around interoperability is something that Catapult looks at and is really clearly important for the energy sector as a whole, and in a lot of the examples that we've just discussed. So now we're going to move on to the roundtable discussion. I'm going to show the 3 questions that we'll move through linearly. But before we do that, Tabitha, I'd just like to introduce the different guests. And in fact, they might want to say a couple of words about themselves. So Jack, would you like to introduce yourself before we start the roundtable discussion? And Tabitha, if you could spotlight Jack, that would be brilliant. Yeah.
Cool, thank you. Hello everyone, I'm Jack Kelly. I guess I'm a machine learning researcher who's terrified by climate change. I've been working in energy for about 10 years now, depending on how you count. I'm co-founder of Open Climate Fix, which is a non-profit entirely focused on trying to mitigate climate change using things like machine learning, and we're currently really focused on solar electricity forecasting using satellite imagery and real-time air quality information and that sort of thing. And maybe we'll talk a bit more about forecasting later. And I've also spent half my time consulting for National Grid ESO on forecasting, and before that I was at Google DeepMind working on forecasting wind power. Thank you.
Thank you. Can I introduce Irene as well?
Nice to meet you, and thank you for having me with you today. I'm Irene Di Martino, based in London, lead Ampex. I've spent more than 20 years now in the energy sector, originally as a power generation engineer, working for most of my career for ENGIE, so in the utility space, looking at technologies to make the power generation most cost effective, and then moved a few years ago to the digital energy space, looking at blockchain, first of all, at the World Energy Council, and then establishing Ampex as a fully owned subsidiary of AMP, which is a renewable infrastructure owner-operator across the globe. I'm very excited to be here today because Ampex is really very much reliant on developing a disruptive digital energy platform that is very focused and very much leveraging AI, ML. So as I'm sure we'll have a chance to discuss more in a minute.
Thank you, Irene. And Aidan.
Thanks, Anthony. So I'm Aidan O'Sullivan, Associate Professor in Energy and Artificial Intelligence at UCL Energy Institute. I'm also a Turing Fellow at the Alan Turing Institute. At UCL, I'm Course Director for a Machine Learning Masters in Energy Systems and Data Analytics, which started 3 years ago, and also lead the research group in Energy Systems and Artificial Intelligence. We work across the energy sector, but I've recently been involved in Europe's challenge on learning to run a power network, which allowed teams from all over the world to compete to train an artificial intelligence agent to autonomously run a grid under a range of scenarios, and various other kind of fun projects involving AI.
Thank you. I've already got about 10 questions for each of you, so I expect the audience to do too. So just a reminder for the audience, we won't be doing live questions now. If you've got any questions, please do post them in the chat, and then after the roundtable, we'll come back and try and get through a couple of those. But I suspect we won't be able to get through all of them. So if you've got 3 questions in mind, maybe only post the best one, so that you know that you've got your best chance of getting your question in. So right now we'll go through the roundtable discussion, and by turn we'll come to the different questions, and then I'll come to the different panelists as well. So the first question is quite high level, and it's really about how AI can be used to transform and unlock potential within the energy sector. And I'm sure there's a lot of exciting ideas out there and in the room as well. Irene, can I start with you and come to you with that question?
Sure, I'm very excited by all 3 of your questions because I think they're absolutely great. And by the way, thank you both, Anthony and Osman, because everything you said to frame the discussion at the beginning very much resonates with what Ampex is here to deliver. So if we think about digitalization and the pace at which it's been advancing, I read a statistics that always I get back to just give the magnitude. More than 20 billion of devices connected to the Internet of Things by the end of last year just gives you the magnitude of the importance of leveraging data and making use of data. And especially as we look at the way we want to meet those ambitious targets of net zero by 2050, I can't agree more with the energy systems catapult narrative. We can't do it without relying on digitalization. And PEX has been working to enable more visibility into the LV network, the low voltage network. If we think about the decentralization, now this involves the emergence of electric vehicles, electric heat pumps, major challenges for network operators. How do they cope with not knowing actually what's happening in their networks? How do they gain visibility in what has been historically a bit of a blind spot? So we absolutely want to use data. We want to rely on machine learning, but we want to also marry two different aspects that rely both on data. One is automation. We know that everything in the energy sector these days, all the solutions that are both at high level, but also consumer level, they're all reliant on full automation, but there's also a machine learning side, which allows us to actually introduce autonomy, which is decision-making that mimics the human brain, but at the same time is seamlessly reliant on technology rather than on the input of humans themselves. So we've been developing a smart transformer, which is going to be in the distribution network in the UK in the coming months, and it's equipped with high frequency sensors. And the whole point, that the very differentiator of this piece of infrastructure upgrade is that it's going to enable us to actually see what's happening down that feeder, to inform not only grid planning decisions for network operators, which are absolutely essential, but I think the most important change, the shift that we need to enable is allowing for active network management, allowing decisions that, you know, Esmond before spoke about fault detection, proactive fault detection, understanding that as we predict capacity across a network and we plan for that capacity, especially as we chase cost-effective solutions with non-wire alternatives, we need to be able to see what's happening down a network. So to me, the biggest enabler and what we need to leverage from a data standpoint and the plethora of data that can potentially come from a whole host of devices, including behind the meter, is understanding what happens down a network and how we then extract value from that set of data with robust algorithms. So to me, that's probably the biggest change that we are seeing, and we hopefully will see more and more as we go through this, both decentralization and leveraging the digitalization to meet net zero targets.
Thank you. Jack, can I come to you?
Sure, yeah, very much building on what Irini said there. Let's see, so I think one point I'm really keen to make is that we can start making progress today on applying AI and machine learning to the energy system. I think sometimes there's a narrative around, oh, well, we've got to wait for much better data to come online. And whilst absolutely we need better data, we need vastly better data, not claiming we don't, I think we do have just about sufficient data to mean that we can start playing with some really interesting and sophisticated machine learning techniques that the wider machine learning community have been developing. So, for example, out there in the machine learning community, folks have been working really hard on computer vision and techniques for processing human language. So things like translating French to English and things like this. And some of the techniques that have been developed in both of those fields are quite possibly really quite directly applicable to the energy system. And to give some support to this, so over the last sort of half year or so, I've been involved with National Grid ESO on building a new forecasting system for forecasting electricity demand. As Usman said right at the top of the conversation, forecasting demand is super important for a whole bunch of reasons. And we borrowed this idea from natural language processing, which is called a transformer, really confusingly, it has absolutely nothing to do with having two coils and passing AC through it. It's all to do with a beautifully simple idea called self-attention, which is where a machine learning system can learn which parts of the inputs are relevant to other parts of the input. Sounds very abstract, but to give a concrete example from natural language processing, often if you have well, anytime you have a sentence with an it in it, you need to understand what that it refers to. So you can kind of imagine drawing a line from the it to the noun phrase that it refers to. And these self-attention systems are really, really good at learning to do that from the data. So no one's coming along and telling them how language is structured, rather you just feed them terabytes of English language and it learns from the data how to sort of connect the dots between different bits of the sentence. And we use the same approach for forecasting electricity demand, where the idea here is that when you look back over the last few days of demand, it's really useful to be able to look at patterns and to be able to associate events in the last few days of demand to identify regime changes and things like that. So where a regime change might be, oh look, the Prime Minister has said that we all need to go into lockdown, so the way that demand will respond to different weather events and things like that will change. And this, to cut a long story short, this approach of taking self-attention and applying it to forecasting electricity demand resulted in a halving of the error as measured by mean absolute error for national demand. This was with no new data feeds. This doesn't require huge amounts of compute. It's all trained on a single machine. And so, yeah, just supporting the idea that there is some really quite powerful algorithms being developed out in the wider machine learning community. And there's probably a lot of sort of low-hanging fruit whereby we can take some of these really amazing ideas and with a little bit of tweaking, I'm certainly not claiming they can be applied completely off the shelf, but with a little bit of tweaking, they can possibly be applied to some energy problems and bring about a really large improvement in performance. But I should stop there because I've been rambling for ages. So yeah, very happy to talk about many of these really interesting questions that are coming up in the chat, but let me stop there. Thank you.
Thank you both. Thank you both. And I think we'll probably come back to some of those key points that you've addressed there. So in terms of time, we'll move on to question 2 briefly. And I'm just looking to see if Aidan is desperate to speak on that question. But we'll move on to question 2, and we can come back to some of these themes as we move through. So question 2 is really, where can AI help improve both decision making and also helping hide complexity within some different areas? So this is really about being part of, a solution, whether that solution is around decision making or whether that solution is around making things easier for the end user. So Irene, please can I come to you first with this question?
Sure, I think it's both of what you said. I think we need to leverage AI to make it both easier and to enable consumer centricity to its full extent. I think it was you that said earlier, Osman, that said the grid is becoming increasingly more complex. And if you just start from the individual node, a house, me as a consumer having to manage the complexity of all the devices that ultimately, if you look at cross vectors, common denominator that ultimately gets into the energy space, both heat, electric vehicles, the supply of electricity, and the fact that we want to absolutely enable that level of decentralization and non-wire alternative that cannot depart from making ultimately the consumers active participants into the provision of flexibility. That cannot happen unless we manage this complexity, making it more intelligible, more interpretable for the users themselves, but at the same time, avoiding that we burden that user with having to provide ultimately inputs, having to action, because if we are reliant on that consistent, repeatable human behavior, we're clearly not going to get to the ambitious targets about unlocking, flexibility from, especially the domestic or the residential space. So for me, the role of AI needs to be this one of enabling consumer-centric solution, making sure that the technology allows trust from the user to delegate decision-making through machine learning. And this is where our autonomy comes in. We've developed what we call a digital energy assistant that we will deploy in the Living Lab perimeter of the energy systems Catapult with independent residential users in the coming weeks. And I'm very much looking forward to that, because I think that, to really have feedback from users on, can we make their energy optimization, and ultimately even enabling additional revenue streams for end users be a thing whilst they contribute to increase flexibility into the system? Can technology really play across the challenges the network operators faces, the national grid faces as they want, local flexibility markets encouraged? And where is the role of the users at this point? Because it's been a passive receiver all the way because of the way the energy system has functioned for over a century. So we do need to look at AI as the absolute key enabler for that consumer-centric approach and making things easier for the user. That's ultimately what matters for us to get that participation at a very massive scale.
Thank you. Jack, can I come to you if you have things to add, or a different dimension or a different example for this area?
Yeah, sure. So I guess picking up a few specific ways in which AI, so earlier I talked about quite a big hand wavy set of ideas to sort of drill down some really specific ones. So it's come up quite a few times already, but definitely forecasting electricity supply and demand. Feels like there's lots of space there to do a lot better. So for example, again, from the research community, there's been a lot of work recently, well, not a huge amount, but there's been some interesting developments recently on nowcasting precipitation. So that's trying to do a better job of forecasting rainfall over the next few hours using a purely machine learning approach. And those have been demonstrated to significantly outperform conventional forecasting approaches over those short time horizons. So it stands to reason possibly that those approaches could then feed into better demand forecasts and better forecasts for renewable supply. And it feels like machine learning probably isn't going to learn a better model of the physics of the atmosphere than sort of forecast models that are built at places like the Met Office. But rather these machine learning models are probably really, really good at pulling in lots and lots of different data streams, some of which might be quite low quality data streams, and figuring out in a probabilistic way how best to take a little bit of information where it might exist in these various different data streams. And that's even true. So with some of these newer approaches, you don't even have to align the data, these different data streams in time and space. You can provide data that is not aligned in time and space. Some other things, so estimating real-time generation and demand. So there's a huge amount of missing data. So, one of the big challenges that folks in the control room have managing the grid is that they just don't know what the system is doing right now. And there's probably lots of room for improvement in terms of estimating how much solar generation there is or how much embedded wind generation, things like that. And then last two, very quickly, helping to balance the grid. This has come up in a few questions. I might write a more geeky answer in the chat. And also helping to map the energy system. So there's the Energy Systems Catapult in the Energy Data Task Force report, what seemed like eons ago, recommended that we should figure out where all the stuff is. We still haven't figured out where all the stuff is. And that's a real problem. And maybe, especially for stuff that's visible in satellite imagery, we can start applying some of these more recent approaches to identifying objects in imagery to identify domestic solar PV and things like that in satellite and aerial imagery. And yeah, there we go. That's a laundry list of thoughts. Let me stop there.
I wish this session was longer than an hour, because we've already heard about some really exciting topics to do with smart devices, making things better for the end user, forecasting, nowcasting, and it was mentioned earlier on in terms of work around autonomous, smart, actually autonomous ways of running the grid that Aidan mentioned right at the outset. So we could almost have an hour on each of these, and I'm aware that we're past half an hour through this. So and I can see that there's about 25 posts in the chat, most of which I suspect are questions and are not being monitored by me, but they're being followed as well. So hopefully we'll leave some time for some questions. But while we have these distinguished guests, let's continue to kind of go through these interesting questions. And we'll move on to question 3. which is really around the different domains and different areas. So that includes academia, industry and innovators. And how do these different areas overlap with AI and energy? How are they engaging with them? And what are some of the kind of recent successes and some of the challenges? And I suspect that all the panelists might have an example, but I'd love to come to Aidan first for this, and then if I could come to the other panelists as well. So, what are some of the recent successes, and how do those different domains work with the energy sector? Because every domain is different, and we're sort of privileged in the Catapult to see them all. But it'd be lovely to hear what the kind of view from different sectors is effectively. So academia maybe to start with. So Aidan, can I come to you?
Sure, happy to fly the flag as the token academic. So in terms of kind of the role, I guess the issue is that we're dealing with a really fast emerging, highly technical, highly skilled area. So academia has a huge role in terms of that's where a lot of the knowledge resides. That's where, computer scientists are trained, PhD students are trained. And at this level, it is a highly technical field that demands this kind of expertise. So I think from an academic point of view, there's engagement is really key, and reaching out through, catapults and working with SMEs and things like this to give them access to AI capability to enable their kind of business, their business models to work. It's not the case that, and I think it is partly one of the issues within the energy system is not every supplier and DNO and even the SO can afford to build massive capability in data science and machine learning. So there has to be some solution, and whether that is kind of consultancy style arrangements or kind of mini projects and collaborations, that's one way to kind of help demonstrate the value of AI in the sector as well. And that can really help kind of make the case to make those long-term investments in the right staff and the right people. And hopefully going forward, we'll see, data science teams the size of tech companies in energy companies. That would be great to see. In terms of some of the recent successes, I guess you would point to Octopus Energy as a company that's really taken a data science kind of viewpoint of what a supplier should be and basing their operations around that. I don't really want to get into naming names and kind of saying this company is better than that company, but also the energy aggregators are having a great impact, and their entire business model is based around forecasting and machine learning. Having an algorithm that predicts the price at the right time and making the right bid and optimizing your asset strategy. And in some sense, it points to inefficiencies in the market and inefficiencies in the forecasting at other levels. But it is kind of a good case of the value of ML, that their entire business model is based around this. In terms of kind of specific successes, just to point to the L2RPN challenge, that was again us working with the French national grid operator RTE, who have a huge research capability, as well as Google Brain and Tenet and other SOs throughout Europe as well. So I think there's room for improvement in the UK in terms of collaborations between academia and energy sector players, and I think it would be good to take a long-term view of some of these as well. But it's really necessary to make the case of that first kind of project of what can be done and what can be achieved in that space.
Thank you. Jack, can I ask if you have things to add in terms of what your view is of I guess you've seen the work that Google have done and kind of the work that the networks have done, and I guess they work in very different ways, but you've kind of been a bridge for that.
Yeah, I guess so I definitely agree with the problem statement that bridging that gap between academia and industry is really, really hard and really important to solve. I think a general challenge when trying to get large for-profit organizations to work together is always going to be who owns all the intellectual property. And I've certainly been involved in projects where from a technical perspective the collaboration looked like it was going to be really promising, but then the lawyers get involved and say, oh well, who's going to own all the IP? we want to own all the IP, and then you hit stalemate. So it feels like, and I would say this coming from a non-profit, but it feels like not being quite so territorial over some of the IP might well be a good way to move forwards and unblock at least that conversation about who owns all the IP. But of course that brings its own challenges. But yes, I guess that's the only thing I would add there. Really keen to leave time for other people to ask questions, that sort of thing.
Thank you. And Irene, do you have points to add, maybe in terms of how innovators work and sort of, you know, challenges that innovators have, which may be challenges different to academia and larger organizations?
Indeed. I mean, if I think about the challenge that we specifically face, and it's not just us, but if I think about the behind the meter technology that we've been developing, we've been involved in several discussions around interoperability of devices. Clearly, it is a challenge. BASE is leading the charge with very groundbreaking work in order to attain that level of interoperability that ultimately will enable that open platform approach across devices. If we want to tap and unlock flexibility behind the meter and therefore go really at a large scale in demand side flexibility, we do need interoperability we need open standards. We need to really change the way the access to APIs currently is, which otherwise requires, extensive and committing bilateral agreements, commercial agreements, especially for innovators that start small like us. Clearly, it's quite a challenge otherwise on top of the actual technical challenge. And I would also like to put the emphasis on another angle of the challenge that needs to be overcome in this space, which is the open data culture approach. I think if I look at the work that Laura Sanders, that I greatly admire, has been leading with the UK's Energy Data Task Force, she's been absolutely championing the need for network operators to open the books on the data. We speak about machine learning, we speak about artificial intelligence in general, but for that to deliver, there needs to be access to as wide as possible range of reliable data. And so I think the network operators can play increasingly more so a role that is absolutely, enabling of the ultimate deliverables that we've all been, stating today across AI. But there needs to be access and sharing of the data that they historically do have. And I am absolutely a big advocate of the whole system approach. This has to be a transverse approach, a multidisciplinary one. And this is why I'm excited to be working with the Catapult. I'm excited to be speaking to even Jack and Aidan today, that this has to be something that gets not only technology developers like ourselves, but domain specialists, academia, regulators. We've not mentioned regulators today, but they have to absolutely also play their part, because this truly is a set of challenges that require everybody's input and everybody's active role.
Thank you. So we'll now wrap up the roundtable section, but we'll still be here. We're not going to go away. I think there's about 10 minutes for questions, and there's 30 comments which I haven't read, but I suspect a lot of them are questions. And it feels like there might be time for 2 or 3. So there'll be some filtering process where the top 10% of questions could be asked. And at this point, I might ask if Simon has been wheeling through the questions and whether there are any that we'd like to put to the panelists at this time. And while Simon's teeing that up, I'll go back to the panel and ask whether there's any one of those 3 questions that they'd like to come back to, or whether there's any of the points raised that they'd like to sort of take forwards or challenge. So we've heard about smart devices and the complexity and end users and specific examples of projects and specifically forecasting and sort of bringing ideas from the very forefront of AI and kind of bring that forwards. Are there any points that you'd like to pick up on now as Simon works through those questions?
I've got the questions ready if you want, Anthony.
Okay, all right, yeah.
So I guess actually before I ask any questions, picking on those, one thing I would say, I guess, is that, we only had an hour today. There are endless topics we could have covered in this, and it's nowhere near enough time. So you know, it's worth considering that the purpose of today, to some extent, was to stimulate discussion. We picked out on sort of 4 areas and some interesting questions, but to start building some ongoing relationships, so we can actually start narrowing the focus down and picking on some areas that are more interesting to jointly follow up in you know, smaller working groups beyond this. And another point, picking up on something that Jack said, actually, it was something I was going to raise anyway, but Jack gave a nice segue to it, which was his point about IP. I guess my point's not so much about IP, but it's about the fact that it's not all about the technology. All right. In some cases, some of the challenges that AI can solve will need other solutions around interoperability, roles and responsibilities across the sector to allow the AI to do its job. You know, in fact, I've been in 2 completely separate meetings this week, including Bayes in one of them, and we talked about situations where it's very sunny, it's very windy. So different parties in there are going to have fantastic AI to optimize. You know, consumers are going to want to buy as much energy as they can and charge their vehicles, or, you know, heat their thermal stores, whatever, using that very cheap electricity because there's an abundance of it. The network operators now are going to have the problem that there's so much demand that they may or may not be able to cope. So they may want to curtail stuff. And there's so many layers involved in here, but they're all handled discreetly. So how do we deal with the AI at a level above the individual optimization for different, both commercial and the network entities? So I think there's some points to consider there. So I don't know, that might be a question point. It's not in there, but for Aidan maybe to see whether you got a view on that sort of layered part of it.
Sorry, could you repeat that? I was trying to answer a question in the chat.
Well, so it's how do we deal with the fact that, you know, it's very sunny, it's very windy as an example. So consumers will want to buy as much electricity as they can because it's very, very cheap. But networks may not now have the capacity because otherwise you can melt the cables for demand in local areas, even in some cases. So how do we deal with the fact that retailers will be optimizing for one thing, behind the meter might be optimizing for consumers, the grid's optimizing for a different thing? How do all those things, have you got a view as to how that can come together? It's not just a technology point, I guess.
Yeah, it's quite interesting, and it kind of, you know, it's almost like coming back full circle to should we nationalize the whole thing again and start over with better technology. So you do have these kind of different needs and different agendas which are problematic. Obviously, I'm not advocating for that, but as a system. But in terms of how you balance those out, I think the DNOs have a much bigger role to play going forward. I think at local level, having more oversight of what's happening. And part of that is going to be, the coordination of all these different actors and their needs coming together. I think National Grid have made projections for the system boundary flows that just look more and more extreme as you go further and further. So you're going to be shifting, 5 gigawatts from region 1 into region 2 and back again in the same day, which is kind of an artifact of the way we're going to be generating and dispatching things with much more distributed control and distributed resources. So in terms of how you pull that together, I think, artificial intelligence is almost, an essential tool to enable people to get oversight, to have better forecasts of what's needed at the local generation level, balancing out the different needs. The idea of energy as a service starts to come in, and, are you willing to turn off the lights for certain customers? Does kind of DSR start to play a bigger role? And are there large generation sites that start to take that in? But I think in terms of the coordination, that's where it really gets challenging. And that's kind of why the job of a control room operator is just going to get harder and harder and harder going forward as we add more complexity. So it seems unfair not to give people new tools as we kind of make their job infinitely harder.
Good answer, I guess. I'm very conscious of time here. One question that came up that I don't think we've really touched on much was around the security considerations of deploying more and more AI, and therefore, decision support and in fact automation, that kind of thing, and things happening with less and less human intervention and much more, I guess, potential for nefarious things. So how do we think AI increases or plays into that space in terms of security consideration. So I guess open question to the panel, whoever wants to answer.
I'd like to, I'm not a cybersecurity expert, but this is truly also at the core of our challenges, and especially as we try and deploy technology that is trying to optimally schedule a much bigger number of assets. There is no doubt that as we have an increasing number of connected devices, the cybersecurity threat increases because the active surface of those possible targets is increasing too. I think we need to essentially understand how to best leverage that machine learning aspect. The ability for a decentralized control system architecture that enables a micronode to effectively understand and go beyond a set of prescriptive rules and make a judgment, an active, analysis and evaluation of what's changing around in its environment. How does that depart from possible conditions that have been, the system has been trained on to recognize as acceptable or otherwise possibly adverse. We're seeing this very much so with the smart transformer, because going into substations of the LV network, the network operators is not going to want to be exposed in any way or form to an increased level of threat from a cybersecurity point of view. And actually, the fact that the smart transformer is equipped with a processor, an onboard processor, and relies on machine learning is going to know what are the operating conditions that are acceptable, and is going to think through anything which departs from that. So if there were to be a threat that translates into its departure from those operating conditions, we would probably actually have an advantage in having something which is machine learning enabled in the network at a substation rather than not. So I think it's how we leverage to its full that machine learning aspect of these technologies. And I'm sure Jack probably can expand as a specialist on what I've just said.
Yeah, no, I agree with all that. I'm going to be very blunt now. I think in order to protect ourselves from cyber attacks, the energy system needs to get enormously better at writing software. At the moment, the sort of current practices of develop a piece of software in-house and then basically don't update it for 20 years, like literally keep it running on the same hardware, that has to stop. We have to get much more comfortable with best practice from the rest of the IT industry in terms of writing automated tests, having a team whose entire job is to continually try to break stuff, and all these sort of things that I think without that we are going to be in trouble in terms of IT security. So yeah, I think as a community, and there are good reasons why, obviously, the energy system isn't great at writing software at the moment, but we need to change really quickly, and the change is pretty big.
Thank you, Jack. So I'm conscious that we're basically at time now. So I'd like to thank everybody for attending today, and particularly to Jack, Irene, and Aidan for participating in the panel. There's some it's really interesting always to get diverse views from different areas. That for me makes it much more interesting to see the different perspectives. As we said in the chat, we'll come back to any questions on there that we didn't have time for today, and we will respond to everybody on that so that we don't miss anything out. And there is opportunity to, as I said before, to get more involved in this stuff. We'd like to form some more specific and more focused sort of working groups to actually take some of these and form some real, potentially, significant, impactful projects from this. So any ideas around that would be great. And the timing is good because it links up with things that are happening with Energy White Paper, which was launched earlier this year, Energy Strategy coming out, Spending Review coming up. We've just, as been referenced a couple of times today, Laura Sands has stepped into the chair again, and we've just launched another digitalisation task force now looking at actually the layers above just the data. So there's lots of ways, and the timing feels to me as good as it can be. 2021 feels like a good year on the back of what was a really bad year with COVID last year, to actually drive some of these things forward. So hopefully from this we can identify some really good ideas and move them forward. So at that point, I think it's now 1:03. So I think, unless Anthony, you've got anything else to say, we'll close it there.
That's everything. Yeah. So thank you to everyone, especially the panelists. Yeah.
Thank you, guys.
Excellent.
Bye.
Thanks all.